Bismillahirrahmanirrahim. So in today's video, we are going to discuss about two topics, their remainder theorem and factor theorem. So first, let us go through the remainder theorem. As you can see, the remainder theorem, it has been stated in your book in this way. If positive polynomial expression p of x, so what is p of x? It is a polynomial expression. It is divided by x minus a. So whenever we divide something by something, there is a remainder, right? So they are saying that when it is divided by x minus a, then the remainder will be p of a. Now, what is the meaning of this? Let us try to understand. Okay. Let us say we have a polynomial p of x that is equal to x square minus 5x plus 7. Okay. Now, they are saying whenever we will divide it by something of this shape, that is x minus a, right? So let us say we are dividing this one by x minus 3. Okay, so if we divide it by x minus 3, that is of this shape, that is x minus a, they, according to what the statement says, that the remainder should be equal to p of 3. One thing I want you to notice, that if there is minus a, here it will be positive a, like p of positive a, not negative. If we divide it by x plus a, then what will be the remainder? P of minus a. Okay. Okay. Now it's trying to prove it, that whether it is true or not. How can we check? Let us do the division and see. But before that, let us try to find out the value of p of 3 first. Okay. Okay. So p of 3, it should be equal to 3 square minus 5 into 3 plus 7. Now x is being replaced by 3. Okay. So 3 square is 9 minus 3 fives are 15 plus 7. Here you can see 9 plus 7, they both are positive, so they will be added. So 16 minus 15, it will give us 1. Okay. Now let us see whether we get the same remainder, same value 1 as remainder or not when we do the actual division. So how to do the division? In our previous video, we learned how to do this division, right? Or in case of polynomial, in this way. So we have to match this x with x square. So with x, what we can multiply to make it x square? That is another x, right? X into x, it will become x square. Now this x will be multiplied with minus 3x also, so it will be minus 3x. Okay, x into minus 3 minus 3x. Now when we do the subtraction, what will happen? The denominator sign changes, as we know. So x square minus x square, they will cancel each other. Now minus 5x and plus 3x, it gives us minus 2x. And here we have plus 7. You can see that again. Now we have to make sure that this x matches with minus 2x. How to do that? If we multiply just minus 2 with x, then it will be minus 2x. So it will be minus 2 here, minus 2 into x minus 2x minus 2 into minus 3 minus minus plus, and 3 2s are 6. Okay, those who are not understanding this division, I would like to recommend you to watch the previous video in which we discussed about addition, subtraction, multiplication and division of the polynomials. Okay. Okay, now if we do the subtraction, then the sign will be changed. So positive 2x minus negative 2x, they will cancel each other. Then 7 minus 6. Finally, the remainder that we are getting, that is equal to 1. So what the remainder theorem says is actually correct. Whenever a polynomial, this is our polynomial, it is divided by something like of this shape, like x minus something. Okay, so that time the remainder that we'll get, it is equal to p of a, right? If we divide it by x minus a, then it will be p of a. Okay, so here what we can write, let us write it in this way, that we consider this one to be p of x, right? So when p of x is divided by x minus 3, the remainder The remainder that we got is equal to 1. Now 1, this is equal to p of 3 also, right? So can we write that it is equal to p of 3? Or directly can we say that the remainder will be p of 3? So where did we get this p of 3? From here, right? If x minus 3 is there, then it will be p of 3. Okay, minus 3. If it is minus 3, then it will be positive 3 here. Now, in the expression, they just replace this 3 with a. So x minus a, and here it is p of a. I hope it is clear. This is the remainder theorem. So whenever, like from now on, the problem that you will in the question you might be asked to solve, like they will give you an expression, maybe it will be q of x, and they will ask you to find out the remainder when you divide it by x minus b. For example, I'm just giving an example. So that time, if they ask you what is the remainder, if they ask you what is the remainder, then simply you should find q of, in this place of x, you have to write p and then find the value that will give you the remainder. Okay. Now, if you divide by x plus b, okay, then the remainder will be q of minus p. Okay. I hope it is clear. Now let us go to the factor theorem. Oh, before going to the factor theorem, let me just make clear why actually whenever we're dividing by x minus b, here we are putting plus b. Okay, we are replacing x, right? See, x has been replaced by b. So why x has been replaced by b? Basically, we consider this one, that is x minus b, it is equal to 0. So that now x is equal to what we will get, minus b. If I change the side, it will be plus b. That is why x is replaced by b. Okay. So in this way, you have to find the value with which you have to replace the x. Okay. Now, the factor theorem. Before I discuss the factor theorem, let me ask you something. If I give you a number 6 and ask you to list the factor of it, now which number can be considered as factor of 6? The number with which 6 can be divided. Okay, like 6 can be written as 1 into 6 and 2 into 3, right? These four number that we have, 1, 2, 3, 6. With all this number, I can divide 6, and what I will get? I will get a remainder of 0, right? Remainder will be 0. So when can I say that whenever we divide a number by another number and we get a remainder 0, then we can say that this is a factor of the number which is divided, correct? Okay, for example, if we divide 6 by 2, 2 3 is 6, the remainder here is 0. So as we got 0, then this we can say a factor. Okay, factor. Now, let us come to our factor theorem. You can see that they are saying x minus a will be a factor. We know that if in order to be factor, what condition they have to fulfill? The condition they have to fulfill is the remainder needs to be 0, right? Okay. Now, whenever we are dividing a polynomial p of x by x minus a, we know that the remainder that we will get is p of a, which we learned in the previous slide. Now, if this remainder p of a, if it is equal to 0, then only we can say yes, it will be a factor of the polynomial. Right or wrong? Hope you understood. Okay. For example, if we have a polynomial p of x, I will take a one that is similar to the previous one, x square minus 5x plus 6, and let us say they are asking to check if x minus 3 is a factor of p of x or not. The question is x minus 3 is a factor of p of x or not. So how can we verify whether x minus 3 is a factor of p of x? So simply what we have to do, we know that when p of x will be divided by x minus 3, the remainder will be p of 3, right? So let us find out the value of p of 3. If it is 0, then we can say that as the remainder is 0, that means x minus 3 is a factor of that. Okay, so 3 square minus 5 into 3 plus 6, 9 minus 15 plus 6, 9 plus 6, 15, 15 minus 15 is 0. So now you can say that x minus 3 is factor of p of x. Okay, so that is how we can check whether polynomial is a factor of another polynomial or not. Okay, by checking. So this actually involves remainder theorem also, right? When the remainder is zero, we can say that it is a factor, and if the remainder is not zero, then we will say no, it is not a factor. For example, the same polynomial p of x, which I have written here, x square minus 5x plus 6. Let us say we are dividing by p of 4. Okay, that means we are dividing by x minus 4 actually. So the remainder will be p of 4. So x square, not x square, x will be replaced by 4, right? Yes. So 4 square minus 5 into 4 plus 6. This equals 16 minus 20 plus 6, 22 minus 22. So as the remainder is not equal to 0, we can say that this x minus 4 is not a factor of p of x. So I hope it is clear. In your textbook, there are some problem related to this factor theorem and remainder theorem. In our future videos, inshallah, we will be discussing about that. So if you have any doubt, then kindly let me know through the comment section. Assalamu alaikum warahmatullahi wabarakatuh.